Welcome. This video will show you how to set up Visual Studio Code for EECS 370. There's a reason that I want to do Visual Studio Code in 370. I found it super useful when I took the course because a lot of our staff know how to do it. I think a lot of our staff know how to do that because it works really well on a variety of operating systems. It works on Windows, Mac, Linux. It's pre-installed on the Kane systems. So if your laptop is ever not working, you need to go into one of the Kane labs, you can totally use it there. Also, it has an integrated terminal, no matter which version you use. And so it's really easy to interact with our makefile and do all the other tools that we have in this class. So our staff generally have limited knowledge on Visual Studio or Xcode, almost nothing on CLion, but we should be able to help out a little bit if you know how to set up your visual debugger. But the nice thing about VS Code, we know how to set up the visual debugger, and it, again, integrates with the terminal really well. And so most of our staff will be able to help you with that. I personally like it because it's very customizable. It's like almost open source. Anyone can make an extension for it. Microsoft has done a good job with that. You can't really do that with the other IDEs, but you can customize anything, and there's also a few things specific to EECS 370 that you can install on your installation in order to make it work. So I will be following the EECS 280 tutorial, and so I'll go ahead and open that up. I'm on Windows. There's a couple different ways to do it on Windows. If you see from the EECS 280 tutorial, I think the best way to do it is by installing a Windows subsystem for Linux, if you haven't done that. The other way is to install some sort of other bash terminal. I think there's like Git Bash and the MinGW project. I've tried both of those, and I find them to not work that well. So if you want to use Visual Studio Code on Windows, I would recommend installing WSL. So the first step, you can go ahead and skip this next part if you're on Mac or Linux or you've already installed WSL. But real quick, I'm going to install WSL on this new computer that I have. So to do that, I'll open up the command line and I will type WSL -- install. I'll allow it to make the changes. And what WSL is doing is it's actually kind of making a virtual computer within your system. So when we get further into EECS 370, we'll see more of what exactly that means, what virtualization can mean. You'll do a little bit of that with the first project, but in the second part, so we won't look at that today. All right, let's see. By default, it'll install Ubuntu. I think that's the easiest one. If you want to use something different, that's fine. I think arcane computers use some version of the Red Hat Linux, which is a little bit different, but I don't think it'll change much for our usage in EECS 370. All right. In the meantime, I'm going to open up the install page for Visual Studio Code. And let's see, I'm on Windows. I'll just download that installer. All right. There it is. I'm going to go ahead and accept all these things. A couple things that I always click whenever I'm installing Visual Studio Code on a new computer. I add this open with code action. So if you right click like a file or a directory in your Windows Explorer, you'll be able to open it up right in Visual Studio Code, which I think will be not entirely useful if you're using WSL, but if you're just doing some text editing, that can be very, very useful. And I like to set as my default editor and add it to path. Adding it to path means I can type like code, just the word code into a command line, and it'll open VS Code for me. All right. Let's check on WSL. All right. And it's going to ask me to reboot. That's okay. And then that's done. All right. So since it's asking me to reboot, I'm going to go ahead, pause this video, and I'll come back with a rebooted machine. And I've rebooted. When I did reboot, it asked me to put in my username and password. I won't show you that part. But now I have WSL installed and VSCode. Before we get too far with VSCode, we do want to go ahead and install the WSL extension. If you do not have this little pop-up, you can go on the left side into extensions, search for WSL, and it should be the first one that pops up. Like we were saying, WSL is this virtual machine, and so this allows VS Code to hook into the virtual machine. All right, so now let us connect, and here we are. All right, so it's going to start up the system, download the server for a second, but I'm going to add a terminal here. And we will start to download our starter files for the first project. So first, this is just a normal bash terminal. So if I print my working directory, we can see where that is. I want to make first a folder for my X370 projects. So I'm going to type the command make dir, and then I'll say X370. I'll change into that directory, and I want another one for my project one. So make directory project one assembler, and I'll go back to my home folder. Next, we need to actually download our code. So you can copy that from the link in the lab one slides. It's also in the project spec, not too far behind. So we will use the command wget, which means like webget, just download. And then we can type in a link and it'll download whatever file from the internet. And then after that, because this is a tarball, it's not just a bunch of loose files running around. We're going to have to use the tar command to unzip it. So I'll use tar xvzf. Let's see, x means unpack, v means verbose, z means it's zipped, and f has something to do with the file. And then I'll type in the name. And then I want it to go into that folder I just made. I guess it won't let me do that. I'll just remove the name of the output folder. And then we can see that after I unpack it, everything is in this folder, the same name as the tarball. So I'll move everything in this starter 1A folder to that folder that I just made. So x370/project1-assembler. And now I cd into that folder we made, and ls, I can see all the files that came in the tarball. All right, and now it comes to this next part that we were talking about with the path. I can just type code and dot. That dot refers to the folder that we're in. Code launches VS Code inside that folder. And so now we can easily open up and we can start to configure our folder within VS Code. All right. So before we get too far into all these things over here, I want to go through a few more extensions. One is the SSH extension. I don't think it's available in WSL. But this extension, if you're connected to the U of M VPN or if you're on campus, will let your VS Code folder run on Kane computers. So maybe if you don't want to install WSL, or if your system's just not working, you can kind of make this a virtual window from a Kane computer and then run everything on Kane. Kane is the best way to test for this class, so I recommend giving this a chance. Some other things that I like, we have a special LC2K extension that a former student made, and this will annotate the special language that we'll use for this class. So I'm going to go ahead and install that. I also like this one extension called Discord Presence. If you have Discord installed, which I don't on this computer, Sometimes, like if you're playing a game, it'll say like playing and then the game name. This will do the same thing for VSCode. So it's kind of a nerdy thing you can do. I want to install that since I don't have Discord installed. And then there are a bunch of themes that you can install. There's like, old terminal style theme. Where's one of my favorite ones? Bunch of green and blue. Let's see. There. I like this one. Yes. That looks pretty cool. All right. So now let's actually look at our files that we have. This main file, the assembler.c, this is the file that you'll be editing for project 1A. So I won't go too much into here for now, but we can see that it has just a skeleton, a few examples of how to do things, but it really won't do anything just yet. We have our make file. Go look on Piazza for a full description of the make file. We have our spec. This is our example assembly code test case that you will use to make sure that you get the correct output. And we've also included the correct output. So we have a couple things here. Now, as we're going through our assembler and we're editing it, we will want to debug it somehow. And there's a couple ways to do that. You can use asserts. You can use just a bunch of prints. You can use a visual debugger. That is my preferred way. And so I want to set up my visual debugger. In order to do that, I'll go to this debug section and I'll create a launch. Oh, and I need to install the C++ extension in order to debug some C and C++ code. We'll do that. And then once that is installed, we'll go back there, create a launch. Let's see. I will debug. And if you want to use my launch, the launch just tells the visual debugger how to set itself up. You can copy it from the slides that we have either on Piazza or in our lab. Let's see here. So I'm on WSL. I'll go ahead and copy that. I'll just paste it there. Now let's look at this a little bit. All these different lines in this configuration file just tell the visual debugger how to launch. We won't really change any of these things up here. For later projects, you can change this to a different project. You can also add a comma and then add some other configurations. If you want project 1A and project 1S eventually to be in the same folder, you can just copy all this and paste it down there, change it for project 1S. And we want to launch the program in our visual debugger. Once we launch it, we need to provide our visual debugger with a way to get to our executable. And so we haven't made our executable yet. If we look at our files, we don't see any file named assembler. We do see assembler.c, but that is different from assembler. And so real quick, I will go ahead and make assembler so that it exists. And I do not have my different command line tools from EX280 yet. Let's go real quick and make sure I have all that. Let's see, they have it somewhere. There we are. There we are. So go to EX280 real quick. It'll tell me to install these tools. All right, and now I can make. So now we see in our files over here this name assembler. You can't open it because it's an executable, just like we saw in X280. But you can use a couple different names in order to refer to this assembler. So like whenever I launch, I'm going to go to my assembler.c, hit the debug button, and this file dir name variable is going to be the directory where this open file is. So it will start in my P1 assembler. You can also use a workspace folder. That is whatever folder appears at the top. In this case, the same thing, but if you had some subfolder where your assembler code was, you might want to use that. There's a couple different ways. You can look at this Visual Studio Code variable reference online if you are having issues. After that, we'll want to specify the arguments. And so you can take a look in the spec to see what we mean by this, but the Project One assembler requires 2 arguments. And so they have to be in separate strings inside this array. And so for now, we're just going to use spec.as, which is the input, and spec.mc, which is the output. Now, make sure you don't rename this to spec.mc.correct, because that will overwrite the correct output that already exists. We want to get some new output. And then I always like to set this stop at entry to true so that it stops at the very beginning of main and doesn't just go on until a breakpoint. And that won't work if you don't have any breakpoints in your code right now. And then scrolling down, I would recommend just copying all the rest of this stuff. But finally, we have this pre-launch task. In order to configure the pre-launch task, you may have done that in 280. That's pretty simple to do with a GCC task, but I like to have a custom make task. And in order to do that, you can copy my tasks file again from our slides. So I'm going to add a tasks.json, and I'll modify it with this. This just tells the Visual Studio Code that we are building a C or C++ file, so it's going to use that extension. Instead of using the default of GCC, I'm going to change it to make. This is the executable path for make. So whenever I call make in my command line, my terminal, this is actually what it's calling. And then I want to pass assembler as the argument. So now whenever I press the play button from within my assembler, it will automatically make. The nice thing about make is that it won't recompile if it's already up to date. So now I can just start my debugger without any issues. So notice how it stopped at the entry. As I go through, I can step line by line, and then I can look at my different variables and things. So most of them haven't been set yet. And there's not much to set if we haven't filled out the rest of the code. But a couple things I want to show you. We have different ways to look at our variables in Visual Studio Code. And so we can add explicit variables if we want by adding them in the watch pane. So in Project 1S, this will be a good place to look at global variables. We don't have any of those in our assembler, but in our simulator we will. And so you might add like state.mem at like 100 or something, or 20, if you want to watch that. Now it doesn't exist in this, so we won't be able to watch that. But you can add any other variable, including in different formats. So let's say I'm looking at my argc. We see that it has the value 3. I can also look at argc or any other number in binary by adding a comma b at the end. By the way, this might not work on Mac systems, but it at least works on WSL and Linux. And so by adding this comma b, I can see 1, 1, which is 3 in binary. I can also add argc in hex, and I think I can add it in octal of 3. So when you're building your output for Project 1A in the format that is in this correct output, these decimal numbers won't really mean that much, but the binary and hex will mean something to you. So I definitely recommend doing that. All right, and that is my tutorial for VS Code. post any questions on Piazza if you have them, and we will see you next time.